Welcome, Hornets, and thank you for joining me today. We're going to be taking a look at assignment number 12, which is found on page 453, numbers 1 through 22, 25 through 29, 41 through 48, and number 72. This is on the washer and disk method and perpendicular cross sections. So we're going to start with number 1. Number 1 is asking us to evaluate the integral that gives the volume of the solid formed by revolving the region about the x-axis. In number 1, the equation is y equals negative x plus 1, and the graph is provided to us, showing the axis of rotation and our curve. In this, we're going to be doing the same basic process. We can see that we're revolving around our x-axis, creating a disk, like so. And so we are looking at pi integration. We're going from 0 to 1, and we're putting in negative x plus 1, the quantity squared, dx. This is giving me pi integration 0 to 1 for x squared minus 2x plus 1 dx. I then get pi 1/3 x cubed minus x squared plus x from 0 to 1. This is giving me 1/3 minus 1 whole, and then we have plus 1 whole multiplied by pi, and my answer is pi over 3. Going to number 2, we have y equals 4 minus x squared, and we're going over the interval 0 to 2, wrapped around the x-axis. So once again, I'm going to go ahead and I'm going to start by drawing my figure. Please be aware, accuracy isn't as important as making sure you have all of the information. So being able to just identify approximation what it is pretty good. Now I like to put down x comma 0. That way I can do my upper minus lower y value to find the r of x. Some people find this to be tedious. I think it's important. If you can figure out what the r of x is at any moment, frankly, you have a better option and a probability of getting it right. Putting it into the formula, pi r squared, which is going to be the 4 minus x squared squared, and we're going from 0 and we're going to 2. Let's make sure we get that right. We're now going to FOIL. So I have pi integration 0 to 2 of 16 minus 8x squared plus x to the 4th dx. This is giving me pi multiplied by 16x minus 8/3 x cubed plus 1/5 x to the 5th from 0 to 2. I have 32 minus 64/3 plus 32/5 multiplied by pi. And if I recall, this is something like 64 or 62/15. I'm going to go ahead and I'm going to find it again. I have 32 minus 64 divided by 3 plus 32 divided by 5, written as a fraction, and it's 256. So I have 256/15 pi, and that's my answer. This brings me to number 3. Number 3 is giving me y equals the square root of x, and we're going from 1 to 4. So, starting off with my graph, I know the graph does this, and we're going from 1, 1 to 4, 2. So 1 to 4, here's my representative rectangle. This piece is x comma square root x. Right down here I have x comma 0. R of x is the difference between them, root x minus 0, the upper y minus the lower y. And when I put it into my formula, 1 to 4, of the square root of x, the quantity squared, dx. This gives me pi 1 to 4 x dx. Now I can do my integration. That gives me pi. I have 1/2 x squared from 1 to 4. That's going to give me 256 divided by 2 is 64. 256 divided by 2 is 128. So I have 128 minus, and I'm looking at 1/2. So 128 minus 0.5 is going to be 255 pi halves pi. There's number 3. This brings me to number 4. Number 4 gives me y equals the square root of 9 minus x squared, and we're looking at 0 to 3. Once again, this is still wrapped around the x-axis. So here's the graph. Here's my representative rectangle. 0 to 3. That's x comma 0. This is x comma square root 9 minus x squared. And therefore my r of x is going to be the square root of 9 minus x squared. Putting this in as pi integration from 0 to 3 for the square root of 9 minus x squared, the quantity squared, dx. I'm now looking at pi integration 0 to 3 of 9 minus x squared, dx. I end up with 9x minus 1/3 x cubed from 0 to 3 multiplied by pi. This is going to give me 27 minus, and you'll notice I get 27 divided by 3 is 9 multiplied by pi, and I'm looking at 18 pi as my answer. Let's go ahead and move to number 5. Now, the whole idea here is you want to keep practicing until you get reasonably comfortable at what you're doing. They give you the equation y equals x squared and a second equation y equals x to the 5th power. My y equals x squared goes like this. Well, that's more my y equals the 5th, and then squared goes like that. My representative rectangle is right there. Wrapping around, we're now looking at the washer method. Notice this is now changed into the washer method because I have 2 different radii, a big R and a little r. Let me use a line just so that you can see it clearly. So this point right here is x comma x to the 5th. This point right here is x comma x squared. My lower point down below is x comma 0. So I have a big R of x, and that's going to be x squared minus 0. I have a little r of x, which is x to the 5th minus 0. Putting it together, I'm looking at my integration at 1 and 0. So I have 0 to 1 pi integration of x squared minus 0, the quantity squared, minus x to the 5th minus 0, the quantity squared, dx. This is giving me pi integration 0 to 1 for x to the 4th minus x to the 10th dx. When I integrate, I get 1/5 x to the 5th minus 1/11 x to the 11th from 0 to 1. That's 1/5 minus 1/11 multiplied by pi. Now, that's going to give me 55, 11 55ths minus 5 55ths multiplied by pi, and I'm looking at 6 pi 55ths as my answer. Number 6. Number 6 gives me y equals 2. Y equals 4 minus x squared over 4. And we're looking at our intersections of negative 3 to 3. So when we draw our graph, let's just go ahead and take a look. There's y equals 2. There's my symmetry. So I'm going to use 2 pi integrated from 0 to 3. I can clearly see that the quadratic is my upper. So 4 minus x squared over 4, the quantity squared, minus 2, the quantity squared, dx. So here we go. We're going to have to FOIL it out. Once again, we're going from negative 3 to 3. We've doubled that so that we can just work with this portion of our graph being wrapped around the x-axis. You'll notice it's giving me a washer because I have that internal piece that's missing. Alrighty, here we go. 16 minus, this is giving me 2x squared plus x to the 4th 16ths minus 4, integrated from 0 to 0 to 3, 2 pi in front, and dx. So when I simplify, I'm going to have 1/16 x to the 4th minus 2x squared plus 12, integrated from 0 to 3 times 2 pi. So I have 1/16 times 1/5 x to the 5th minus 2/3 x cubed plus 12x from 0 to 3. Now the only value that's really going to matter is the 3. So I have 3 to the power of 5. That's 243. I'm going to do it off to the side here. So I have 243. And we're looking at 16 times 5. That's over 80. I am subtracting. Let's see, that's going to give me 27 times, that's 54 thirds. I am then adding 36. Keep in mind that at the end, we're going to multiply our result by 2 pi. So let's take 243 divided by 80. We're going to subtract 54 thirds plus 36. We're going to write this as a fraction to begin with. Then we're going to multiply by 2. And we end up with 1,683 40ths pi. And there's my answer for number 6. Let's go ahead and now move to number 7. Now at some point here, I'm going to start moving forward a little bit more quickly, but for the beginning of this, I think it's important that you see what's happening. We're now wrapping around the y-axis. Our equation is y equals x squared, which I want to change into x equals the square root of y. Right y minus left y, this is 0y. This is x square root of y comma y. And our r of x is the right minus the left. So the square root of y minus 0 equals our r of y. So we have the integration times pi from, and once again, we're going from 0 to 4. So 0 to 4, we're going to put in square root of y, the quantity squared, dy. This gives me pi, integration 0 to 4, and I have y dy. So pi, 1/2 y squared from 0 to 4, that's 16. 16 divided by 2 is 8, and my answer is 8 pi. Number 8. Number eight, once again, 1/4 of a circle. We have y equals the square root of 16 minus x squared. And we are going from 0 to 4. This is y squared equaling 16 minus x squared. So I get x squared equals 16 minus y squared for x equaling 16 minus y squared to the square root. Finding my representative rectangle or line, this is 0 comma y, and this is the square root of 16 minus y squared, y, and I now can find my r of y. Pi integrated, and we're going from 0 to 4 again. So 0 to 4, and we have the square root of 16 minus y squared squared dy. For pi, 0 to 4, 16 minus y squared dy. This is giving me 16y minus 1/3 y cubed from 0 to 4. So I have 64 minus 64 thirds, and that's multiplied by pi. Now going to find what is 64 minus 64 thirds. Written as a fraction, of course, is 120 thirds, 128 thirds pi. And there we go for number 8. Let's take a look at number 9. Number 9 is giving me y equals x to the 2/3 power, which I'm going to change into x equals y to the 3/2 power. And we're going to be going from 0 to 1 is my interval. The graph looks like this. There's 1, here's 0, here's my representative rectangle as a line. That point right there is 0y. This point is y to the 3/2 power y. R of y is the right minus the left. Y to the 3/2 minus 0. Putting it into my formula, 0 to 1 of y to the 3/2, the quantity squared, dy. Leaves me with pi integration, 0 to 1 of y cubed dy. And this gives me 1/4 y to the 4th from 0 to 1. Therefore, I end up with pi over 4 as my solution for number 9. Going to number 10. Number 10 gives me a drawing already. Looks like that. We're going from 1 up to 4. Here's my representative rectangle. They've written this as negative y squared plus 4y. So I'm going to go ahead and put it directly into the point. And 0y, that means my r of y is going to end up being the difference or that result from the right x minus the left x. So I have negative y squared plus 4y minus 0. And the formula that I'm going to use is 1 to 4 for negative y squared plus 4y, the quantity squared dy. I'm going to end up getting y to the 4th minus 8y cubed. Let's see, then I'm going to have plus 16y squared dy. Putting this in means that I'm looking at 1/5 y to the 5th power minus 8/3. Pardon me, that should be 4y to the 4th. 2y to the 4th, excuse me. Let's make sure I divide correctly. Then I have plus 16/3 from 1 to 4. And lo and behold, there went my lights, everybody. As expected, I'm going to put this into my calculator, multiply by pi, and then I'm going to end part 1. So let's just take a look at this. We're putting it into our calculator. So I have 4 to the power of 5, and we're dividing by 5. We're subtracting 2 times 4 to the power of 4. And then we have plus 16 times my y squared. So we have, let's get rid of that. So that was to the 4th power. Then we had plus 16 times 4 squared. And I'm dividing that by 3. This gives me the first piece. And I want to write this as a fraction. So I'm looking at negative 3,328 minus, I'm now going to put in the 1. So I have 1 divided by 5 minus 2 plus 16 divided by 3 written as a fraction. Alrighty, let's just double check this because it looks like we have some kind of an error. And I just want to double check my work. I have this, it's my upper equation. My y is the 0 wrapping around the y-axis. So I have my upper, my right minus my left. Aha! Nope, that's right. It's correct. Put it in and squared it. The 4th, we have minus 8x cubed. So this twice. Then we have this twice, 16y squared. Alrighty, I'm just getting a negative, so I'm going to put it in again. This time I'm going to check my work all the way back at the beginning, just so that I can make sure that I'm not getting a negative volume. Remember, if you get a negative volume, it does mean you've done something wrong, and you're going to want to go back and double check it, just like I am now. Just going through and checking all of my work. It's to your advantage to do so. Alrighty, I am not getting a negative anymore. Writing it as a fraction is 153, and it is in the fifths. So I'm actually getting a total of 153, and this is to the 5th power multiplied by pi. And that's the answer that you should end up getting. Alrighty, so there we go. This constitutes the end of part 1, numbers 1 through 10. I will continue in part 2 in just a moment. I hope this was good. If you like it, please make sure you click like. Otherwise, give me suggestions. Thank you very much, and be kind to each other. Bye-bye, Hornets.